Well, I've been having some water pump issues. A couple times I've lost prime. It wouldn't prime up, giving me trouble. That's kind of aggravating me, and I've noticed my PSI is kind of low too. I just put me a gauge. Well, I'll walk back here and show you what I did. So you know, I tapped into the, of course it's showing 0 now because I've unhooked the water pump. But before I was only getting 40 PSI. So I just tapped into the water spigot on the back side of the washing machine. So something's not right. This pump, I bought this new maybe 2-3 years ago. So I'm going to take it apart, see what it looks like inside. Just a few Phillips screws, see if I can notice any wear, and decide what I'm going to do with it. Well, there it is. Pretty simple. Take the screws loose. There's the diaphragms. Let's see what it looks like. Oh, ain't that pretty? Alright. Looks like it's going to take 2 hands to get this apart. So I did get my little water pump apart. All apart, actually. It's pretty neat how it works. From what I can tell, I kind of see this stuff on pressure washers. I work on pressure washers too. And it's just, everything's hard to do one-handed. But I call this like a wobble plate. How am I going to spin that and hold it at the same time? Well, that ain't going to work. I gotta come up. I rigged up something here so I can spin this to show you how it works. Because this is the armature here on the electric motor when it's running. See how that wobbles? And that's what causes the wiggles the diaphragms back and forth, which causes the, I guess, the push-pull effect, which sucks the water in and pushes it back out. Pretty neat how that does that. And you can kind of see how it works. See, it's got this ball bearing in here, but it's got this bushing. They press in the ball bearing, and this bushing has an offset to it, and that's what creates the wobble. So it does the wobble, then these diaphragms stroke back and forth, and these bolt on to the plate like that. Get in there. I'm gonna get me a GoPro one of these days, and I won't have this issue. There we go. All right. Of course, this bait plate bolts up solid to the motor, and that as those diaphragms wiggle back and forth, it creates the push-pull. And then you got this other plate, which has all the like the intake and exhaust valves, the rubber, but that's kind of what I call them, intake and exhaust. Anyway, back to this thing. This is the rubber valves, and I went ahead, so because I had this trouble, I thought, well, I'll just order me a new motor and be done with it. But I found out no one had one in stock, and we're fixing to take off in a few days, so I went ahead and just ordered these. The Amazon had these diaphragms and the valve plate in stock, so I'll have it here tomorrow, so I can put that together. And the motor itself operates, it runs, but another thing that's taking it apart. I noticed this is called the commutator down here. If I can focus in on it. Can't see it very well, but it does have grooves in it. If you run your fingernail across it, you might be able to see them. So it does have wear, and I've only had this maybe 2 years, 3 at the most. So I'm kind of surprised the amount of wear it's already taken. And then when I look inside the motor housing, it's got a lot of brush material where the brushes are worn. So I'm going to clean all that out. And you can see the brushes themselves, they've got small marks on it. So I'm going to clean them up. That's something else I noticed in taking this apart. If you ever have one of these that quit, you put 12 volts to it and it just don't work. I'm assuming this is probably a thermal fuse. It's a little fuse device in here. So if you have one of these and you apply 12 volts to it and it doesn't work, take it apart and check this little thermal fuse. There's probably, the motor may have overheated at one time and popped, and will cause it to quit working. I don't know where you could find one, but I'm sure, like everything else, Amazon will probably have it. But anyway, going back to what I'm going to do next, I'm going to go down to the garage. I'm going to put this in my drill press, get me some emery cloth, and clean this up, get it nice and smooth. I'll do that. Then I was kind of looking at how this thing operates, which is pretty cool. But my old pump I had like 3 chambers, and it was bad to pulsate. You turn it on and it goes rump, rump, and the water would just kind of squirt and pulsate. But these do a much better job with these 4 chambers. And I guess one way it works, you've got these 2 settings in here. This is the bypass. I guess it keeps, once you build up, say, I think it's like 62 psi, it opens up. Another thing I was going to show you here, if you look inside this chamber, this is where the water comes in. And the water comes in here, and you got your valve plate. It sits here. Then you got this little rubber diaphragm, sits on top of that. So as those rubber diaphragms are flexing, it draws water in and then pushes water out constantly on all 4 chambers. So you can see how that kind of works. Then, of course, so this is all this area here. All this area is the intake side. But then you got this O-ring. This is the pressure side once it's going out. And this here's your little switch. This is like, I guess, I'm trying to think of this little switch. When the pressure drops, it kicks on like I think like at 40 psi or something like that. When it senses, when you open up the faucet, the pressure momentarily drops and it kicks on, and then it begins to flow. But it's also a check valve, so it keeps the water. If you blow air into this, air will not come past it until you push down on it, or the water pressure pushes down on it. Then the water will flow out of this chamber down the outlet to the rest of the RV. So then also here's the on this piece here, that is the bypass. So when the pump, I guess that helps keep the pump from pulsing like the old ones used to do. They'd shut on and off, on and off. This will continue to run and just kind of maintains pressure. And the way it does it is because you got a little slot here, and there's a little rubber diaphragm in behind that. This is the pressure side, and then this is the suction side. So once it gets up so much pressure, that diaphragm will press, and it's spring loaded on the other side, and it'll allow the water to flow from the high pressure side to the low pressure side and just circulate around and around. So that's how that works. You got a little Allen screw here, so that sets the bypass pressure, and this screw, Allen screw, sets the pressure. I guess like a differential switch. Well, what I would kind of call it. So when the PSI gets to a certain level, a low PSI, it tells it to kick on. So that's the best way I believe it works from where I'm looking at it and from what I've read. So I'm going to go down the garage and do some cleanup on this and see if I can't work on getting it put back together. Well, I realize I misspoke, because after I got to thinking about what I just said, well, that doesn't make sense. So what this does, this is only a check valve. It has nothing to do with the switch. It just is a valve. I was thinking it was attached to the switch, because I took a voltometer thinking I could hook a voltometer up to these terminals, and I thought I would push on this button and it would trip my meter, kicking the switch on and off, but it did not do that. So that's why I took it apart. So when taking this apart, that's when I realized that little valve here that's all it is. It's just a check valve. So the way the pressure switch works is this little diaphragm. It's got a little bitty diaphragm right there, and it's amazing the amount of pressure it takes, whatever setting it is right now, because there's that little Allen screw. As you tighten it down, it takes more and more pressure to push in. Hear that click? So it takes a pretty good click or pressure before it trips it off. So I believe I'm assuming factory set for about 55 psi. It'll kick on, and then as it drops, it'll kick off. Anyways, interesting. That's what I've learned so far. Well, I'm down here in my garage, and down here with my poor man's lathe, and we're going to clean up the commutator. You see all those scratches in there? I'm trying to get that looking better. See a lot of scratches. So I got me a little block of wood here. There it is, block of wood, a little sandpaper. Put this on, get her spinning. sit here and do this for a little bit, see how it turns out, and I'll update you. Looking better. See what an improvement that is? That was with, I think it was a 180 grit initially. Get that focus a little bit better. So it really cleaned it up a lot better. So now I'm going to take it, I got me some 600 grit. I'm going to run on there and smooth it up a little bit more, get the scratches out of it. Alright, she's looking really good now, nice and shiny. There's something I was going to mention to you. Anytime you're working with a little bit electric motors and you're cleaning up the commutator, depends on the motor design. I've noticed there's sometimes the material in between these, I think it's called mica. It's a hard plastic. And sometimes you got to take a razor blade and cut those down. Or anytime you're cleaning one of these motors up, you want to make sure, because over time as your brushes wear, the old brush dust can fill up in these grooves, and that can cause the brushes to kind of bounce along, and you don't want that. Then that causes arcing. So I'm just taking this razor blade and going through each one to make sure it's clean, there's nothing in there. And this is the way this motor's designed, it's good and deep. But I have seen them to where the mica would be right up to the surface of the commutator, and you'd have to cut it down with a little tiny screwdriver or a razor blade. So that's what I'm doing, and I'll polish on it just a little bit more, and then I'll start putting this little motor back together. All is cleaned up, back in the RV, time for reassembly. I got things laid out here, because when I initially took it apart, I marked my housing so I could put everything back the way I found it, even I marked the diaphragm the way I took it out. So, but one thing, because I'm going to have to do this with two hands, is when I'm putting this armature back in here, these ceramic magnets are very powerful. So you're going to suck it right in. So be ready for that if you take these little motors apart. And then I know these brushes are probably going to be a pain getting them repositioned and fighting those little bitty springs. So I'll see how that's going to turn out in just a second. So here's a tricky part. When you get the, where's my spring? You get the spring in here and your brush, because the brush is always pushing out. And if they're pushing out and you got that plate, all that assembled, well, there's no way you can get the brushes held back and put together at the same time. So when you first take it apart, this piece and this piece seems to be bonded together, but you take a razor blade and pry them apart. So once you do that, you can gain access to the back side of where the brushes lay in this channel. So what I came up with, and I think will work, is once you put the spring in there, push the brush back where it will clear the commutator. See how it's pushed back? It'll clear the commutator. Then I took just a little ring connector for a wire, crimp-on. It's a very thin piece of metal. And I was able to wedge it down between the plastic and the brush, where it applies just enough tension to hold it in place. So I've done the one, and I'm going to do the other, and then that should allow me to just drop it right down in here, and we'll be good to go. Alright, so you see I got the brushes now in place. I went in there real easy, because I got them held back with those little clips. The brushes are held back, so it goes right over the commutator without an issue. And then I just pull these out. Got it in there tighter than I thought. There we go. You hear the snap. And get the other one out. There we go. Now the springs have snapped the brushes back to the commutator. So I'll put my metal cap on and put all these screws, and of course I gotta get my bearing lay in there. I'm gonna put a couple drops of 20 weight synthetic oil on that little bushing, see if it won't spin a little bit better. And that goes like this. I'll get all this together and I'll fire it up and we'll do a little test, see how it does. Well, in thinking about my water pump issues, because a couple times I've lost prime, it's acted up, I thought I'd crawl under here to check my lines going into the tank. Because I got to thinking, you know, if I had a loose fitting, then it could be drawing air, causing some of my problems. But I checked it and it's fine. This is the line going straight back to the water pump. And if you got an RV with all these PEX lines, pick you up one of these wrenches. They're really great. It's got that little metal piece on it. So you can get into a spot like this, it's really tight, You get in there and snug it up. Make sure it's good and tight. And I did find I did have a line up here that was slightly loose, but that's the fill lining. So I took it apart, and you can see I put some Teflon tape on it, put it back on there, got it good and tight. So it's a good idea to get into your RV and check things like this. Years ago, you can see a coupling way back there. Years ago, I had a leak, and I had to get in there. And you see my insulation. That's another project I did, gosh, 4 years ago maybe, because I realized in tinkering around this thing, we was out in South Dakota, really cold, and I realized, man, there is no insulation. I mean, all you got is this sheet metal. You know, we're outside here, so if it's 20 degrees outside, the only thing you got between the 20-degree weather and your water tank is this thin piece of metal. And so your basement furnace has to work double time to try to keep your water from freezing. So that's why I got this insulation in there, and I put that in. You see, here's a great big piece here, but I put that stuff in there years ago, and it's worked pretty well. It stayed nice and dry. I was concerned maybe about, you know, if it would cause any sweating issues, but it hasn't. So that's worked well. But anyway, I'll show you up here up front. I'll crawl up here. All right. See, this is where the lines run. And there's the line that runs to the water pump. And once upon a time, you can see, if you see right there, there's a little piece of door protector. That stuff you put on your door when you open up your car door and not hit the car next to you. Well, from the factory, they laid this line right on top of that sharp metal edge, and you can still see some of the white plastic. Well, the water line was sitting there being cut on it. You can see the spot, the notch it cut into it, but I laid that on top of there too. Now it's plastic on plastic, so that. But if I hadn't caught that, eventually I would have had eventually I would have had a hole right there and a leak. So that would have been a bad day. So all in all, the basement area all looks dry. So I'm going to put all this back together, then start working on that water pump and see if I can get it fixed. So she's working a whole lot better now. You can see my PSI here. Let me trip it on some water. So we're pumping up to, look there, we got about 50, maybe 58 or so PSI. So yeah, before I was only getting 40. So when I'm running the toilet, it drops down to about 20 or so. But then it builds back up and shuts off. 40, 50, that's about 58 psi. And I'll show you the water flow, because before my little faucet here, I wasn't getting just a trickle, not a very good flow at all. But now it is much better. And try the sink. Oh yeah, kicking butt now. So I'll show you what one more tweak I did. Get out here. Of course, here's where the water pump is mounted, and on that little set screw. Oh, where's my finger? There it is. Right down that set screw there. I gave it about a half turn in to increase my PSI slightly. Of course, if you go too much, it'll never shut off. It'll run constantly. So you got to be careful you don't go too much, thinking you're going to get it more PSI. You'll burn your pump out because it'll never shut off. Of course, I got to mount my pump back. But you know, one thing I like about my pump, because where it's mounted, I can hear it. Whenever it kicks on, I can hear it in the RV. Because some people don't want to hear their pump, but I want to hear it. So if there's a problem, if I spring a leak in the middle of the night, I hear the water pump running, I know to investigate and see what's going on. So I think this is going to wrap this up. So I got to thinking while I was working on this water pump issue, monitoring the water pressure, PSI, I thought it was pretty handy, and I thought, well, that'd be nice to have all the time. So what I did, I went out and got me this little Y connector. So I'm going to put it right here on the washing machine spigot. Then I'll split off of it. I'll have my gauge on one side, and then hook up the washing machine on the other. So that way I'll always have my pressure reading. Let me see how that works out. Well, you can see I got it in here. It was a tight squeeze, but we got it. And I had to reverse this line because normally the one with the elbow fitting goes on the back of the machine like this. So I reversed it. It's coming out straight on the back. But by doing that, I was able to get enough clearance to get it all put together. And so now, anytime I want to see what pressure I got, all I got to do is open up that door and I can see my current PSI. So if my pump begins to get weak over time, or if I'm in a campground that's got super high pressure, at a glance I'll know what it is. Pretty cool. Well, and so for a recap, you know, because this is just kind of an experiment. I was fixing to pull out here in a day or two, and I ordered the new diaphragm and valves, but they haven't showed up yet. But I did that because a holiday weekend coming up, I didn't know if I'd get it here in time. I went ahead and ordered those. So I'll just keep those on hand. If I ever need them in the future, I'll have them. They weren't that much. But, you know, as a recap, if you need to adjust the pressure on it, I found this little information on the internet somewhere. I just Googled this, the bypass adjustment procedure, and I printed this out. But this is a 5/64 Allen wrench is what you'll need. And right there is your pressure switch, the one in the center. So if you turn that screw in just a little bit, if you have a pressure gauge, it's very handy, so you know exactly what you're getting into. But remember, if you go too far, it won't take much and the pump won't shut off. You got your pressure too high. Back it off a little bit. Anyway, that's what I've learned so far, and that's what I know, and it's working for me. Hope it works for you. Thanks for watching. Have a great day. Bye-bye.